All right, and we're back. So I'm going to skip example 2. Since it's a line, its tangent line is going to be the line. I'm going to do something a little bit iffier. Let's look at example 3. So if I want to find the average rate of change from -3 to -1, well, then I can just use the formula. I know the slope between 2 points is the y value at the one point minus the y value at the other point over the x value minus the other x value. Excuse me. So if I'm going in and doing this, I'm just saving myself some time, right? Should I save myself time? You know what? I'm gonna. On the AP exam, they're going to expect that we can do stuff like this by hand. And if you know that you struggle with the arithmetic of like squaring a negative and stuff like that, I do recommend spending the necessary time and going through and practicing. The more you practice this stuff, the better off you are going to be. So when I go in and I do this, I wind up getting -1 to -4. Or sorry, -1 has a y value of -4. And -3 has a y value of -4. And then the bottom, -1 minus -3. So it's -1 plus 3. So that's 2. Wait a minute. -4 plus 4. That's 0. So it's 0 over 2. So m is equal to 0. Okay. So now it wants me to estimate the instantaneous rate of change at x is equal to -2. So again, the way that we do this right now is, so we were going to use -2, and let's use like -2 point, a couple zeros and a 1. And so they look like they're the same number, but they're slightly off from each other. And so that's going to be really important. So we're going to do -4, 6 of the 9s, okay. And then that's a lot of 9s. So I subtracted my y values on top, and then so I did this one minus this one. So I need to make sure that I do this one minus this one. I need to follow the order. And so that's going to be here, positive point over negative point. Okay, so we just kind of do our arithmetic and get our stuff. I'm going to double check that I got the right number of zeros. Thanks, calculator. Wow, that's lazy. So that means we start at 1 and we move the decimal place 1, 2, 3, 4, 5, 6 that way. So we're good. Divided by. This is really tedious, and I understand that. So our instantaneous rate of change is approximately -0.001, which, if you think about it, I'm guessing it's actually going to be 0. Now, there's a lie that we're going to have to talk about somewhere in here. Oh wait, never mind. Yeah, no, we can talk about it. The average and the instantaneous, they're not always going to match. I don't know if you remember earlier. They didn't match earlier. So they're not always going to be the same thing. So the equation of the tangent line at x is equal to -2. Okay, well then if I want to find the tangent line at -2, then all I need is to do y minus y1 is equal to m times x minus x1. We call this point slope form. So our slope, we're using 0 for our slope. X minus our x coordinate of -2. That changes to, instead of minus -2, we can just write +2. Makes life easier. And then y minus y1. And the y value in x is 2. I think it's -5. I just want to double check. Yeah, negative 5. Okay. And so there's the equation of our line. And again, like some of you are going to prefer to do y equals mx plus b, and you're more than welcome to. No, you're not more than welcome to. You're regular welcome to. Because more than welcome is like, you totally should do it. I don't think you should. I'm faster. This is faster. And like, yeah, we totally could clean this up. We could say this is y plus 5 is equal to 0, because the 0 distributes and kills it all. And then subtract the 5 from both sides and get y equals negative 5. Like, yeah, you could totally do that. But which of these is the more correct equation of the line? And the answer is neither. They're both fine. So, I think that's all I care to do for those. Let's see. Suppose the object is traveling along a straight line to calculate the average velocity. Okay, so only other thing I want to talk about, and then we're actually going to skip the majority of the rest of this. So if I want to calculate average velocity, this is a physics term. Colloquially, which colloquially means like when you're just talking to people you know, or talking to friends, or talking to people on the street. If you ever heard the word velocity, you've probably associated it with the word speed. This is like speed, but not quite the same. So they're not quite the same thing. So like you've got your speedometer in your car, and it's telling you how fast you're going, but it's not telling you what direction you're pointed in. Velocity is allowed to be negative. Speed, however, speed's always positive. Like if I'm going 25 miles an hour that way, we'd say we're going 25 miles an hour. But we could use velocity, and we could be like, oh, well, I'm going to say that this is a positive 25 miles an hour, or this is a negative 25 miles an hour. Velocity tells us which way it's going. And in this class, we're only ever going to do like two directions, like forward, back, or up or down. We're not going to do any complicated stuff. In physics, you learn how to do like diagonals and stuff. We're not doing that. We're just doing like forward and backward and stuff like that. So, and in general, we're going to say this way's positive, that way's negative, or this way's positive, that way's negative, just like it is on the coordinate plane. So, beyond that, this works the exact same way. So if we like know our position, the average change of position is called velocity. So that's the end of that. We're going to move into more important, or more relevant to where we are right now. Oh, I'm so sorry. We're skipping all the way through these. We're going to skip to page 15. All right, and so I'll see you in the next video.